The kidney is an amazing organ. It does something called osmoregulation, which means that it regulates the amount of salt and water in our bodies. And the purpose of it, of course, is to get rid of nitrogenous waste. But there's many animals who have had adaptations to the kidney or other sort of systems besides the kidney that can accomplish the same thing for them. So we've studied invertebrates what the kidney looks like. We've drawn this picture and gone over the parts of the nephron. Let's see how other animals have adapted that. It pretty much depends on what their environment and habitat is and what their niche in that habitat is. I'm going to look at several different possibilities: freshwater, marine, that is seawater, and terrestrial. And what we'll see here is how the environment is in relationship to the animal. Pretty much it has to do with the amount of salt. So we talk about this as being tonic. If something's hypertonic, more salt, or hypotonic, less salt. We also can talk about it as osmotic. So I just want you to be aware of those words there. So tonic means the amount of salt in relation to the environment, and osmotic, basically the same thing really, means how much osmotic pressure it has. So if something's very salty, it would be hypertonic, but it would also draw a lot of water in from the environment, so it would be considered to be hyperosmotic. So let's take a look at freshwater here. So who are we talking about? Your trout, your carp, your bass, that sort of a fish here. So there's our fish over there. So what's its problem? Well, its problem is it's saltier than the lake that it's in. The lake is freshwater, so it would be considered to be hypertonic or hyperosmotic if you want. Which way would water be moving then because of osmotic pressure? Water would be moving from the lake into the fish. So water moves into the fish trying to dilute the salt of the fish. And that actually means that the fish is drowning by just being in the lake. So what's its solution to the problem? It develops a really large kidney, and it just urinates all the time. So out comes ammonia. That's why when you have freshwater aquariums, you always have to change the water all the time because they're putting out ammonia. In comparison to that, let's look at a marine fish. Somebody's in a saltwater situation. So who's saltier then, the fish or the ocean? Well, the ocean would be saltier. So the fish is actually hypotonic or hypoosmotic to the seawater. So which way would water move now? Water would move out of the fish, right? It's getting pulled out of it by the salty water. So the fish is actually drying out simply by being in an ocean of water. I know that's really weird. So what is the solution? Solution is the fish drinks all the time. So you may have noticed a lot of saltwater fish always kind of have their mouths open and so forth. And what they're doing is they're trying to get water back into their systems here to replace the water that they've been lost because that they're in a salty environment. Now there's some special guys who live out in the ocean, out in the salt water, sharks, shrimps, and crabs. Same problem here. They're living in a saltwater environment here, but their solution is a little different. They have adapted their internal salt concentrations to be just as salty, or isoosmotic or isotonic if you want, with their environment. So they're the same amount. Now they use different salts. They use urea, for example. That's one of their sea salts. And they balance themselves out. So which way would water be moving? Would not be moving in or out at all, right? They're at equilibrium. So they're perfectly balanced with their salty environment. Who else is out in the ocean there? Well, we have some mammals out there, right? Whales and dolphins. And if you ask little kids, how do they drink water? Most little kids would say, oh, well, they kind of wait till it rains and then they turn upside down on their backs and they drink the water as it rains down. But that's not true. In fact, they don't drink at all. Why not? Because they are even saltier than the ocean. They are hypertonic. The water then moves into them, right? and they filter the water, and so they never have to drink. So they filter seawater, and they turn it into fresh water that they can use in their bodies. Okay, let's get out of the ocean and let's go back on dry land here. Let's see land animals or terrestrial work here. What's our problem? Well, our problem is evaporation. We actually lose a lot of water every day simply by evaporation to the air from our skin. But we've come up with a very easy solution to the problem. We drink water. It's not a big deal for us. So we just simply drink the water to replace it that we're losing from evaporation. There are some special terrestrial animals. You may have watched, what is that show, Most Dangerous Catch, where they're crab fishing out in the ocean. You always see these birds flying around there. And you wonder, how are they drinking? Are they drinking salt water? Yeah, they actually are drinking salt water. And how can they do that? If you look at the nose of a bird, you'll see that there's little, like, holes on their noses there. And those are actually salt-secreting glands. And so what happens is that they can filter water through them, and the salt kind of drips out of them, very attractive, right above the nose. And they extract out just clean, fresh water. Also, there's the desert rat, right? Desert rats, they live out in the desert, not much water out there. They rarely ever drink. Why is that? Because they have a kidney which doesn't just absorb a little bit of water, it reabsorbs all of the water. And so urine comes out really as a solid. They reabsorb all the water. They don't have any loss at all, so they really don't urinate at all. Well, those are pretty much large animals, but there are some other animals that have developed completely different systems besides the kidney. So let's look at the worm, for example. They don't have kidneys, so what do? They have something called nephridium. Nephridium. So that's their brand of kidneys. And what nephridiums have is a bunch of cells called flame cells, right? And these guys take the fluid that has the nitrogenous waste, and they reabsorb the solutes and return to the body fluids there. So they have a series, long canals like this, right, that are made of these flame cells, right? And here's where fluid comes down from the body, and that's where they extract out the water from the nitrogenous waste. We don't need to know a bunch of this. We simply need to know instead of kidneys, they have nephridium, and the nephridium are made of units called flame cells. One more example, and then we'll finish up here. The insects, they don't have kidneys either. They have something called Malpighian tubules. So body fluids are drawn into these Malpighian tubules by osmosis due to potassium. And the body fluids pass back into the body, and the nitrogenous wastes go on, and they're emptied into the insect's gut. And that's how they're gotten rid of. So again, we don't need to know a lot about insects. All we need to know is instead of kidneys, they have something called Malpighian tubules.